Okay, let's actually get the lights off here. To some degree. You guys like those lights off? You get to see better. Sometimes people say they see better. All right, let's see. Let's see who's at home. We got about 9 people at home. So Caesar, good morning. Steve, good morning. Alfred, Hector, Angie, Antonio, Panawa. Good morning to you. Good morning to all you guys that are here. Now, I'm going to warm up today. Okay, we're going to warm up with something called, this is kind of like the S portion. Remember, this is 241S. You say, what do you mean the S portion? You do some review. So anyway, let's take a look. See if you guys remember some beginning algebra. Right? Some beginning algebra. You go, what do you mean beginning algebra? Factor out the what? Greatest common factor. Okay, so I want you guys to warm up with this. See if you can remember, because it's going to be about what we have today as well. Okay, so I'm going to give you guys a little bit of time to warm up, wake up. Let's get going here. All right. right, everybody. Good morning to you. Let's take a look at this. Right, this is the S portion. So what do you guys remember about factoring out the greatest common factor? You guys remember, this is kind of what I show beginning algebra students. Okay, there's an algorithm. You say, what's the algorithm? Well, what do you guys do first? You guys remember? You need the greatest common factor of 2 and 8. So what is the GCF of 2 and 8? Do you guys know what I'm saying? So for the number 2, the factors are 1 and 2. For 8, 1, 2, and 4. These are the numbers that go into, like for example, 2. These are the factors with a 0 remainder, 1 and 2, right? And then you say, well, what is common here? Well, what's common is 1 and 1, 2 and 2, but what is the greatest common number? It's 2. So the greatest common factor is 2. Now, really, you go next to the variable x. But if there's not another variable here in terms of x, like an x squared, right? We can't even say x is common. Is that right? So you got two terms. You got the 2x and you got the 8. So these are kind of the easiest in some ways, comparable to note. I want you guys to compare and contrast. You could get 2x plus what? 8x squared. Okay? What I'm saying is, you guys remember here, x is common. But what's the GCF for the variables? Right? The GCF for x and x squared is always x to the what? Smallest power. Okay? So this is going to be x to the smallest power. Now, that's not so important for us here because we're not factoring those at this point, okay? So the point I want to make to you guys is if x is not common, it can never be the GCF. Is that right? It can never be a part of it. So here the GCF is just what number? 2. Okay, so I want to let you guys know the problem that we have, the greatest common factor is 2. So this is the first step in the factoring out greatest common factor process. So if you want to call that step 1, right? Okay. Do you guys happen to know what step 2 is? Step 2 is to find the quotient. What do you guys think? What does quotient actually mean? Do you guys know what quotient means? It means to divide. You say, so what am I dividing? I'm taking the original expression that they gave you here. Okay, and I have to divide by the GCF. That's what you do in general. Okay, so if I say to you, let's get rid of these colors here. What was originally given to you? 2x plus 8. Okay, I take 2x plus 8, and I have to divide both by, what's the GCF? 2. And so you get to distribute your division, right? So you get 2x over 2 plus 8 over 2. And what does that give you? That gives you x plus 4. Okay? So, ladies and gentlemen, you're kind of done with the process. Do you guys know what I'm talking about? You're kind of done because now you got step number what? 3. Is to take the original expression, 2x plus 8, and you write it as the GCF times the quotient. This is like your answer step, okay? GCF, which was what? 2, and then what was the quotient? X plus 4, is that true? So, ladies and gentlemen, what did you just do? You factored out the what? The greatest common factor. Okay, that's what this process is. This is from beginning algebra. All right, you guys okay with that? It's going to be something we look at in detail today. So this is kind of the S portion. We don't have to do the S portion at the end. We could do it in the beginning. We do it wherever it's convenient for us, in case you guys didn't know. So did you guys remember this process? How many of you guys got these answers here? Anybody here get these answers? Well, if you didn't, it's clearing out the what? The cobwebs. You guys okay with that? And then you got 3x minus 12. So I'm going to let you guys know you got 3x minus 12 now. So for 3x minus 12, let's go through the process, right? What's your greatest common factor here? Do you guys know? Factors of 3 are the numbers that go into it with a 0 remainder, like 1 and 3. What about 12? 1, 2, 3, 4, 6, and 12. Those are all factors. And what is common? 1's common. What else is common? 3 is common. Isn't that the greatest? Greatest common factor is 3. Okay, you guys okay with that one? And then what do you guys do with this, right? You take the what? 3x minus 12. You divide by 3. You take the original expression because you're trying to find the what? The quotient. Quotient is to divide. So you divide both terms by the greatest common factor, and what do you guys end up with? This is x minus what? Minus 4. Okay, so let's write this all down now. What do you guys get here? What's this going to be? 3 times x minus what? 4. So you factored out the greatest common factor. Okay, so this is the GCF. All right, you guys okay with that? How many people had this one too? Okay, if you didn't, it's a good exercise to review. Is that right? So what about 4x plus 20 now? What do you think we can do? GCF is 4. What's the quotient? Do you guys want to know? After a while, what can you do? We can take a look at this 4x and divide it by 4. What do we get? Good. Keep the sign. And then we take the what? Take the 20 divided by 4, and what do we get? 5. And this is where some people say, hey, Mr. Judge, did you just look at it and get the answer? And I'll say, no. Once you get the GCF, divide both of those terms by the GCF. Okay, you say, how? By this exact what? Process. Okay, because this is called factoring out the what? Greatest common factor. Okay, and then number 4, let's do number 4 here, ladies and gentlemen, because number 4 is special. Is that right? Why is number 4 special? If I look at factors of 5, what are the numbers that go into 5 with a 0 remainder? It's only 1 and 5 because 5 is prime, right? It's a prime number. What are the factors of 6? 1, 2, 3, and what? 6. So let's find the common factors. Are they any other common factors? No. So do you guys want to know what that GCF is? The GCF is going to be 1. So if you said, am I going to write this as 1 times a quotient? And I'll say to you, you will, but what do you guys notice? What's anything divided by 1? Yes. So you might say, that's 5x minus 6. Yes. In other words, this is already factored in some sense. Okay? Now, we call this situation something special. If the GCF of numbers here, like in this case, 5 and 6, is 1, anybody know what that's known as? What do we call that? We call that what? Being relatively what? Prime. It's a relatively prime. So that's a special situation. Sometimes things are already factored. Okay? So I don't know if you guys have known that. Now, number what? 5 here is also going to be interesting. Let's kind of copy that. Let's see what number 5 will be. GCF of what? 6. What is that? 1, 2, 3, and 6. These are all the numbers that go into 6 with a 0 remainder. They're called factors. Okay, so they're factors. What about 20? What are the factors of 20? What are the numbers? And do it systemically. Start with 1. One will always be there. 2. Okay, what else? Does 3 go into it with a 0 remainder? No. 4. What else? 5. 6. No. 7. Remember, we need a 0 remainder. 8. No. What's the next one? And let me give you guys a secret. Once you get to halfway, there are no other factors. The last one will always be the number. Notice this. What's half of 3? What's half of 6? See that there? See what I'm saying? See this halfway? So for the GCF, that's kind of a special situation. Once you get to halfway, you're not going to have any other factors. It's very important. All right, now let's try to find the common factors, right? Common. What does common mean? The same. So 1 and 1. What else? 2 and 2. Any other common factors? No. So notice your GCF is what number? It's going to be the number 2. Is that right? Now, the quotient we get is going to be what? 6x plus 20 divided by 2, which is 6x divided by 2. 20 divided by 2. This will be what? 3x plus 10. So you have the GCF, and then you have the what? The quotient. So how do you guys write your answers? 2 times what? 3x plus 10. And you are what? You are done. All right, number 6 here. So how many people got that one correct? Just curious. Anybody? Few people? Is this clearing out the cobwebs? What do you guys think? Do you guys see this in high school? You know what I'm talking about? You guys high school students? You guys see this here? Do they still teach that? Do you guys know? No, they don't teach this stuff anymore? You mean factoring? Oh, not doing it the way I'm showing you? It's kind of odd because there's no other real way to do it, in all honesty. I'm going to show you guys some other things here because it's warm up, This is kind of warm up, but yeah, interesting. Yes? Relatively prime. 2 numbers. The GCF of 2 numbers is 1. It's called relatively prime. Yeah, they call that relatively prime. What are factors of 12? 1, 2, 3, 4, 6. We're halfway. So what does that mean? Yeah, exactly. That's kind of an interesting. Hey, this looks familiar. 12 and 20? No. So that's kind of an interesting fact. What about 20? 1, 2, 4, 5. What else? 10. Oh, then 20. Okay. So it's kind of interesting that the procedure I show you guys is what I show a beginning algebra class. This is factoring out GCF. And yeah, getting the quotient. So I'm trying to think what other way would there be to get that quotient? 1, 2, what else is common? 4, anything else? No. So this is actually from first principles. This is by definition. GCF is what? 4. You guys okay with that? Now we need the quotient. So I'm not even sure they would say 4 times what here? Do you guys know what I mean? That's really what? GCF times quotient. Okay? So you have 12x minus 20 here, ladies and gentlemen, divided by 4. And 12x over 4 minus 20 over 4. That's going to be what? 3x minus 5. So you get 3x minus what? 5. GCF. And what do we call this? The quotient. All right, you guys okay with that one? What do you guys think? Is that pretty good? Well, I'm going to share with you guys something that's amazing here, something you may not even realize. You may not realize this. If I said to you, I have 3x plus 5, okay? I want you guys to know something here. We can factor out the leading coefficient. This is a new factoring. This is something that's new for you, maybe. Okay, do you guys know what I'm talking about? You say, what are you talking about, Mr. Judge? Yeah, what's the leading coefficient? Do you guys know what the leading coefficient is going to be here? Yes, 3. You say, how do I know that's the leading coefficient? Well, it's the leading term, and coefficient means number. So whatever number you have multiplied to that variable, it's called the leading coefficient. Now, what do you think this actually means here? Do you guys know what this means? It means I can write this as 3 times a what? Quotient. Outstanding. You guys are learning. I should make another worksheet called Algebra for Trig students. What do you guys think? I already have one for Algebra for Calculus students. Algebra for Trig, because there's these new, I don't want to say tricks, but there's these new ideas that you may not have seen. And you go, I don't know. I never knew I can factor out a leading term. Yes. How do we get that quotient? Do you guys know? What do you do? Yeah. Take the 3x plus 5, and what do? You divide by what? That 3. Okay, it's not the GCF. So that means you get 3x over 3 plus what? 5 over 3. The 3's cancels. What's the quotient? It's x plus 5/3, ladies and gentlemen. I'm going to write this down here. So you might say, can I write this as, right, 3 times x plus what? 5/3. The answer is what? Yes. Okay, you guys okay with this? What do you guys think? Is that pretty good? You can factor out a leading term. And then you might say, Mr. Judge, where are you going with this? Well, 2x minus pi over 3. So where I'm going with this is here. We're going to factor out the leading what? Term, that leading coefficient. The leading coefficient here is 2. So I'm going to have to write this as what? 2 times a what? Quotient. We're going to factor out that leading coefficient. So you take 2x minus pi over 3 divided by 2, which is what? 2x divided by 2, pi over 3 divided by 2. We get cancellation. This is x minus pi over what? 3 divided by 2. You guys know what's going on here? You got to do your what? Fraction divided by a whole number arithmetic. So we've seen that. So what's this going to be? Pi over 3 times 1/2, or pi over what? Pi over 6, ladies and gentlemen. Okay? So you have the following. The quotient, ladies and gentlemen, you factored out the 2. You have now, it's not x, it's what here? Is it x? Yeah, it is x, sorry. You have x now minus pi over what? 6, ladies and gentlemen. So we can always factor out the leading what? Coefficient. Okay, you guys with me on that? Isn't that amazing here? Some more arithmetic factoring algebra. I didn't learn arithmetic until I took all these courses. And then I go, oh my God, there's all this arithmetic. So I actually call math really in some ways arithmetic. Pi x plus pi over 2 now. I'm going to try to do that one. Pi x plus pi over 2. What are we going to factor out? The leading coefficient, the pi value here, right? So you go, oh, does that mean I'm going to write this as pi times some quotient? Yes. Okay. So you start by taking the expression that they gave you right up here, right? This is the two-step process. You can divide everything by what? By pi. Pi over pi, pi over 2 divided by pi. And there's an x. Okay. Cancellation, x plus pi over 2 divided by pi, which will be, this is where your arithmetic comes in, ladies and gentlemen. Right? Pi over 2 times 1 over pi. What do you think just happened? That's 1/2. So what is your quotient going to be? This quotient is what? X plus 1/2. That quotient goes right up where? Here. So the final answer, pi times x plus what? 1/2. Okay? Which one? On the bottom there? Yeah. Okay, ladies and gentlemen. And again, you guys have these videos there. Where are these videos found again? Because sometimes I'll get emails and people say, I don't even know where your lecture videos are, Mr. Judge. Where are these found? You guys know? It's in the module section of Canvas titled Lectures. Good job. You guys see what I mean? Anyway, technology is wonderful, but I got to tell you, let's do 1/2 x plus pi over 3. Okay. Should I have you guys try this on your own? I'm going to have you guys try this. This one's an interesting one. Number 2, I'm going to give you another one. Two-thirds x minus pi over 6. Okay, I'm going to have you guys factor out the leading what? Coefficient there, okay? I'll give you guys some time to do that. Let's see what you guys get. All right, ladies and gentlemen, let's take a look. What did you guys get here as an answer? You guys want to tell me? What does that equal? 1/2 times. Is that the answer? Remember, I divide by what? 1/2. Is that right? Remember, this is how we do this arithmetic. Probably right in here, folks need to do some what? Right? You guys remember that? What's this going to be? Pi over 3 divided by 1/2, or pi over 3 times the reciprocal. And I guess that's 2 pi over 3. So you guys good with that? So there you go, 2 pi over 3. So sure enough, that is correct. Okay, you guys see the work there? All right, what about this one? What'd you guys get here? 2/3 times x minus, I think you say, Mr. Judge, I think I know what I have to do. Take the pi over 6 divided by 2/3, is that right? Pi over 6 times what? 3/2. Oh, what is this? What did you guys get? I think this is going to end up being what? Pi over 4, ladies and gentlemen. There you go. Is that right? Because you're going to multiply down here. You simplified. 2 times 2 gives you that what? 4, and you keep the pi. So there you go, ladies and gentlemen. Easy what? Is that pretty simple? And you say, well, why are you bringing this up? Because originally, I wanted you guys to warm up with these kind of questions, right? In other words, what I'm going to suggest to you guys here is this. Let's go down here for all of these here. Okay? What you're going to do here now, just for these, for today, I'm not going to go into all the detail of graphing because I have already, right? You want to determine the amplitude, the what? The period, and the interval of one what? Cycle, or we forgot that phrase called phase shift. And your interval of one cycle. Because did you guys see any homework questions on the graphing that look like some of these things? You guys see what I'm saying? And you might have said, oh, that Mr. Judge, how mean. He's going to make me do what? Learn this on my own, right? So this is 2. This is what? X minus pi over 6. Is that right? So here's what I'm saying. This portion here, we need to write as what? 2 times x minus pi over 6. Okay, you need to factor out that leading coefficient. Because what are they going to say to us now? This is going to be sine now of what? 2 times x minus that pi over 6, ladies and gentlemen. Okay? Now, there's a 1 here, and so I have A, I have K, I have B. Is that true? You say, what do you mean? Well, A is what? So my amplitude, the absolute value of 1, which is 1. Okay? My period is 2 pi over K, which is 2 pi over what? 2. So my period is really what? Pi. Okay? And then this is, remember the key? X minus whatever comes after is the B value. So what's your phase shift? It's pi over 6. That's right. Okay, great. You got all that information. Now the interval of one cycle, if you guys recall, I is what? B b plus p. So, what is b? Pi over 6. Pi over 6 plus what? Plus pi. Pi over 6, and this is going to be what? 7 pi over 6. You say, why, Mr. Judge, is that 7 pi? Because in order to do my arithmetic, what do I need? That's 6 pi over 6. Is that right? So, ladies and gentlemen, take a look. We now have everything we need to graph. Is that right? So that's kind of the idea. Okay, so you guys have all the stuff you need to graph. I don't know what color to use. Oh, I think we're using, was that pink? You guys probably can't see that. So is that kind of all the arithmetic we've been doing, ladies and gentlemen? You see what I'm saying? We replace this one with what? Pi x plus, I think that was 1/2. Is that right? We already did that one earlier. So I have 1 cosine pi x plus 1/2. Okay, because we factored out that leading what? I even kept it the same color just so you guys can see it. That's my k value. This is my a value. And then I want to put a warning over here. This is x what? Minus a minus, because my phase shift is actually what? Negative. You guys remember that? The phase shift is actually negative. So when I try to find the amplitude, it's the absolute value of 1, which is 1. My period again, 2 pi over k, which is pi, and that's 2. My phase shift is what? Minus 1/2. Interval of 1 cycle, b plus p. So this is negative 1/2. Negative 1/2 plus, what's the period? 2, yes. So if you guys remember too, again, some of the things that I gave you on that worksheet, and I might even do the solutions there, right? The arithmetic. What's 2 minus 1/2? Do you guys know what that is? Yeah, you're going to put this as 2 and 2. So it's really negative 1/2 plus what? 4/2? Okay, you guys okay with that? And what's negative 1/2 plus 4/2? Isn't that 3/2? There's your interval of 1 cycle, ladies and gentlemen. I don't know what color. I guess we use pink. So this is how we factor to find all the important details we need to graph. So now you're able to work on the graph information, ladies and gentlemen. Okay, so I wanted to make sure you guys have that. And then here, right? We already did this. This is 1/2 x plus, what was that? Is that 2 pi over 3? I think so. So y is 1 times sine of 1/2 x minus a minus 2 pi over 3. A, what's this? K. And then this is what? B. Okay, you ready to write this stuff down? What's the absolute value of 1? 1. 2 pi divided, what's k here? Is k 1/2? How do you guys do that arithmetic? A whole number divided by a fraction again. What do you guys do? It's the whole number times the reciprocal. So what's your period, ladies and gentlemen? Your period's going to be what? 4 pi. Okay, you guys okay with this? What do you guys think? Is that amazing? So everything that we've been doing, you know, we're in good shape. So the interval of one cycle, the definition, remember b plus p. So here's my interval of one cycle. What is b? Negative 2 pi over 3. So I start at that, and then I have to add a multiple of what? 4 pi, ladies and gentlemen. So how do I start to do the arithmetic here with fractions? Okay, what do you guys remember? Remember, what is this? 3, is that right? So multiply the top by 3, bottom by 3. So what does that arithmetic really give you? And that negative 2 pi over 3 plus what? 12 pi. So what's this going to give you? It's 10 pi over 3. So here's your interval of one cycle here. 2 pi over 3 up to 10 pi over 3. All right, you guys okay with that? What do you guys think? Pretty good? Now you could do all your graphing technique here. So if you said, wow, okay, Mr. Judge didn't talk about that. Well, he talks, you know, he what is this one? I can't remember. Is that pi over 4? Oh, I guess I could remember. Okay, and I think, yes, there we go. A, what's this? K and B. So A, K, and then what? And phase shift. Because it's always what? X minus. Whatever comes after that minus is what B is. Okay, you guys okay with that? That's always a question that people have. So amplitude, absolute value 1 is what? 1. Period. 2 pi over, oh, what is K? 2/3. Did you guys see that here? So what do you think I should do here, right? 2 pi divided by 2/3. Notice my arithmetic. 2 pi times 3/2. So my period's going to be what? 3 pi. Amplitude's 1. Okay, you guys see that there? What's your interval of one cycle? You start at B, you end at B plus P. So we're starting, if we say, what is our B? Our B, oh, we didn't even write that down. B is what? That's pi over 4. That's the phase shift. Okay. So we now have pi over 4 plus 3 pi. So again, it's arithmetic with what? With our fractions. Is that right? Notice the denominator's 4. What do we have to do? Multiply the top by 4 and the bottom by 4. Is that right? So you get pi over 4 now plus what? 12 pi over 4. What does that give you? 13 pi over 4. So here's my interval of one cycle. It's going to be pi over 4 and then what? 13 pi over 4. And I guess we're using pink. Pretty in pink. So remember the amount of arithmetic we're doing. I'm thinking of, I think I have to eventually, if I go to my website here, let's go to the website. Remember, 241, I can't see, that's not 241. 241. Arithmetic for trigonometry. Might have to do, see some of these things we're doing? I don't know, maybe you guys can't see. Let me try to scroll in. All right, you guys see some of this stuff here. Isn't that doing arithmetic with whole numbers and fractions, even signed? And what else do we have? Some quotes, some division. And then what? Determine the midpoint. Okay, we need that stuff. All right, and then perform the indicator operations. I started putting pi there. Just show people the difference, you know. And then, hey, midpoints between these numbers with pi. Isn't that all the stuff we need? All the little detail. And you know what I'm going to add here? I think I'm going to add factoring out the leading term. Man. What do you guys think? Wouldn't that be pretty good? You're like, Mr. Judge, you're serious? You do have to learn arithmetic? Yeah, you can't move forward without it. You guys don't know that, right? And it's in every math class or science class. There's arithmetic. So don't look at it like a chore and you go, oh, poor me. I got to do this, right? Who's it going to help at the end of the day? It's going to help you guys. That's the whole idea, right? It's a whole idea. Anyway, all right. Now, here we go, ladies and gentlemen. You guys ready for the next iteration? What do you guys think? Wasn't that good stuff? And we should celebrate with some what? Pancakes? What do you guys think? Celebrate with pancakes? What would you have this morning for breakfast? Pancakes? Waffles? Sausage? No? What would you guys celebrate for breakfast? Eggs? Gotta think, what would I have? Garlic rosemary potatoes, and eggs. What do you guys think? Not bad? That's how I'd celebrate. Let's see if you guys remember this here. Which one we just did? Okay. No, you know why? Because if you go back right in here, remember that format I gave you? It has an X minus. Okay, so B is always, if you remember the format that they gave you here, and it's the format I gave you too. You know, you have A sine what? K X minus B. Something like that. I think so. Yeah, something like that. Where you say, oh, that K has to be positive. B can be negative. So here's the detail that people overlook. This is X minus. So whatever comes after that minus sign is the phase shift. So in this case here, what came after the minus sign, you guys see what I'm saying? What's that B value? Pi over 4. And I know what happens because sometimes when people see a plus, right? Maybe they see, oh, you got y is 2 sine 3x plus pi over 2. Okay, that's not in the format of x minus, is it? Right? It's not, it doesn't look like x minus. So you have to remember that the opposite of a negative is a what? Positive. So now you got the x minus, and then so you have this what? This is your b value. So it's opposite. You know, so in this case, if it was a plus, your b is what? Negative. If it's already subtraction, you're good to go, and b would be positive. So it's kind of opposite if you want to remember it that way. I remember it this way personally. It's simple. I got a format. It has to say x minus. Okay, that's the format. And you go, what if there's a plus? Well, it's minus a minus, you know. Anyway. So I want to share with you guys something here. If they say y equals secant x, and even y equals what? Cosecant x. Okay? That when you look at these graphs, I'm going to share with you guys how to graph secant and cosecant. It's very simple. Okay? You see, if you ever see secant, what do you guys want to remember? You want to recall a few things. That the reciprocal of what? Cosine is secant. And for cosecant, the reciprocal of cosecant is what? Sine. Okay? So if you look at this first one, you look at the second one, it's almost like they're saying graph 1 over what? Cosine, because that's what secant is. Remember these reciprocal identities? These are the reciprocal identities here. Okay, so look at this. Here's secant and, 1 over cosine. That's a reciprocal. And for cosecant, it's 1 over sine. Okay, you guys okay with that one? Now, this is what this really means. Okay, here's what you guys want to do. I think you want to do it in steps. I'll say step 1. Graph the cosine curve. When you have secant. You want to graph cosine. What happened here? What am I writing in the... Right? You say graph cosine, because that's a reciprocal of secant, right? So what does that cosine curve look like even? You guys remember? The general cosine curve. Can't even draw straight lines. So cosine starts at the top. It goes to the x-intercept. Starts at the lowest value there, minimum, x-intercept, and you come back here. Does everybody agree with that? Okay. Now I'm going to do a ghost curve here. You go ghost curve, Mr. Judge. Okay. So is that the cosine curve, by the way? Right. And I want you guys to notice something here. This is important. Look at the x-intercept values. What are your x-intercepts? Pi over 2, and what's the other one? 3 pi over 2. Now, this is for cosine. You say, am I looking at this and this? And I'll say, yes, those are the x-intercepts. You guys okay with that? All right, ladies and gentlemen. So far, so good. But what are you really supposed to graph? Not cosine. Do you guys look at this? This is secant. So I'm going to bring this down here. Anybody know about vertical asymptotes? Right? You have a rational function. You got these things called vertical asymptotes. Vertical asymptotes is where your denominator equals 0. And we already know that cosine is 0 at pi over 2 and 3 pi over 2. This is why you want to draw that ghost curve for cosine. Because a vertical asymptote is a line that you never what? Cross. Okay? So you found this line here. These are my vertical asymptotes for secant. Okay? Because in the denominator of your rational, you could never have 0. Is that right? Secant is 1 over cosine. We're looking at this right here. Right? So you have that vertical asymptote. It's where it's 0. You never cross these lines. And then, ladies and gentlemen, we got to remember what a reciprocal is, right? If you ever look at the graph of secant, you see this point? This is this point 1. Well, if that's on cosine, what's 1 over 1? It's also 1. You with me on that? And then this point here, somewhere over here, I don't know, maybe somewhere you got this 1/2. Okay? What's the reciprocal of 1/2? Is it 2? So when you look at a secant curve, you're going to see this curve never crossing that asymptote because you're taking reciprocal values. Now over here, reciprocal of -1 is still -1, but you'll see all the other points here, the reciprocals are reflected there. Okay? These are now reciprocals, and you never cross those vertical asymptotes. Reciprocal 1 is 1, and all these points, when you reflect them, about that line, you take the reciprocal. This is why you see what you see here, ladies and gentlemen. This is the graph of secant. And yes, the interval of one cycle, again, is from 0 to 2 pi. So the point I'm making, if you ever need to graph secant, you know what the real graph you're doing really is? Cosine. And then you're able to now do what? This idea I just showed you. Get rid of the ghost curve. Get rid of all the ghosts, ladies and gentlemen. And this is the classical demonstration of what curve? Secant. Now, let me go to my favorite graphing program, Desmos. Y equals what? I wonder if they have the secant. They do. Y equals secant. And then I'm going to do this from, and you guys know I can't do red for graphs. Sorry. I'm going to restrict the domain from 0 to 2 pi, right? Because like sine, it's periodic. So I'm going to say, how did they do that? I think it was 0. Okay, 0 less than or equal to x, less than or equal to 2 pi, right? Okay, you guys see what I'm saying in blue? What do you guys see here? You should see exactly what I wrote. And if you said this, I want you to compare and contrast. Y equals the cosine curve. Again, from what? 0 to 2 pi. Zero less than or equal to x, less than or equal to 2 what? Pi. And then what's this? Color, let's change it. Oh, it's going to be a ghost curve. You see my point? It's exactly what we did in the ghost curve. The ghost curve here, if you guys really look at the detail, that's the graph of cosine from 0 to 2 pi. So we do have these asymptotes, like I shared with you guys there. These are lines that you never cross, vertical lines. But this now is your graph of secant, ladies and gentlemen. So the key, moral of the story is what? If you want to graph what? Secant, draw what? Cosine. In the very way we did. I know I got rid of the cosine curve. What do you think the other one would be? If you want to graph cosecant, what do you draw? Sine. I don't know if we have time. I think we're out of time. You know, so maybe I'll look at Desmos here and show you, generally speaking, right? If we said y equals, generally speaking, y equals, here's my function of, what do we say, cosecant? Okay, we're out of time though. And then here is y equals, what's that other function? What do we say? Sine. You're going to see a similar kind of relationship that we'll see tomorrow. But ladies and gentlemen, this is how we start graphing what? Secant and cosecant. Just simply graph sine and cosine and go through that exercise I showed you by the reciprocals and the vertical asymptote. So we'll summarize that tomorrow. We'll conclude our graphing tomorrow. What's tomorrow? Is that tomorrow Wednesday or Thursday? Oh, it's Wednesday. Oh, okay. Could be even Friday. All right. So ladies and gentlemen, I'm going to have you guys read your book for tomorrow, which is on 5.4. Okay, 5.4, and we'll see you guys when? Tomorrow. To get a highlighter there. What curve starts up here and then goes down to the x-intercept and the minimum value, x-intercept, and again the maximum value? What curve is that? Cosine. So the reciprocal of cosine is secant. You guys just graph secant. So this is, again, if you want to graph any secant curve, you want to graph what? Yeah. Graph the cosine, and then you could do this, you know, the asymptotes, the vertical asymptotes through the intercepts, and you start to sketch the reciprocal, and that's where this comes from. Now, you might say, okay, what about secant here? Okay, just to kind of introduce you to that graph. Y equals secant x, okay? Now, if you said, oh, cosecant, got to wake up. I don't like that desktop went out. Oh. Horrible. Sad. Okay. So this would be 1 over, what's the reciprocal of cosecant? Sine. So we're going to have to graph the sine curve, right? So we're going to go through that again. It's a very, very simple process. So in your life, if you said, what are the graphs of these things? These are the graphs. Just remember that you're going to have to graph sine. So that's kind of why you wanted to go through your homework and graph sine. Right? You guys know what I'm talking about? You want to be able to first do that. Okay, and I'm going to do a little bit here. More, just in case. So it's going to go through the sine curve. If you guys remember, it goes to 1, -1, 0 to 2 pi, right? And pi over 2, and 3 pi over 2. So the sine curve, again, where does sine start? You guys remember? Starts at that origin, and then it goes where? It goes up here, back down. I'm going to change colors. I'm going to go to the intercepts, and then we're going to go to the minimum value, and then we get back to the, to where we're going. Okay, you guys okay with that? And that's your traditional curve now. And then you say, well, what happens if we're going to do the reciprocal, right? Remember, you have x-intercepts for this sine curve. What do you guys know about any rational function? There's your denominator, where that denominator equals 0 for sine. That happens when x is 0. Okay? That happens when x is what? Pi, and when x is what? 2 pi. Okay, now you say, why am I calling that VA? What is VA short for? You guys, it's your vertical asymptotes, yes. Right, you got the vertical asymptotes there, so what do? We draw what? These nice what? Lines here. Okay? And then you say, but you're trying to graph the reciprocals. Well, the reciprocal of 1 is 1, and then like we did yesterday, all these points around it, believe it or not, they're fractions, they're less than 1. So taking the reciprocal of a fraction less than 1, you're going up and down forever that way. Same thing over here at -1, you're never crossing these vertical asymptotes. And so, ladies and gentlemen, you got the graph of cosecant here. Now, I didn't bring, I lost my computer that had your textbook. So I'm going to have to go to my notes on that. Let's see if I can. Yeah, it went back on. I got it. What's that? Yeah, that's what happened. Anyway. And so, ladies and gentlemen, you're going to see here, this is the graph of what? Our cosecant curve. Yes. Mm-hmm. Well, again, remember when I said something like this here for you guys. See all these points here? They're smaller than 1, right? So something like this here would be 1/2. So we're saying down here, sine is 1/2. So what is 1 over 1/2, right? 1 over 1/2 is going to be, doing that arithmetic, is 1 times 2, right? So this point here is reflected up here. And then similarly, all these points in this curve here, the same thing. This point gets reflected. So for me, it's very simple in that way because these points get what? Reflected. And then down here, the same thing is happening. This would be, you say, hey, is that kind of like where -1/2 would be? Yes, but reflected now would be where -2 is, right? And I guess we can call that, I'm not sure, negative 2 might be down here. I apologize there. Let's get that point. So it'd be here. So it's kind of simple in that way that all these points on this curve are now reciprocal because, you know, the function is a reciprocal. So all those fractions there that are under 1, like 1/2, 1/3, become 3, become 2, 1/4 becomes 4, you know. So that's kind of just a very simple way to remember just that reflection in that way. Well, yeah, a negative number, reciprocal, like for example, if you said, hey, is there like a negative 1/4 on sine? There is. What's the reciprocal of negative 1/4, right? It's actually negative 4. So that's going to be way down here. And the closer you get to 0 and so on, this is why this goes on forever. So this is the explanation, like for the other curve for cosec, and this is why you see what you see. I'll get rid of all of these. And again, the final graph does not have what? This here. Okay? What is this? Continue. Yeah. So I'll erase this here in our notes. There's your secant curve, and then here's going to be your what? Right, cosecant curve, just so you guys know. Okay, you guys okay with that? That's just kind of, so just to kind of give you an example, right? You say, okay, they're going to want you to graph y equals, I'm going to do now this, 2 secant, let's say 4x. And then you might say, well, how do I handle that process? Okay, so I want you guys to note here, what you do is to graph what? Yeah, graph y equals to what? Cosine 4x. What's your amplitude? 2. Good. What's your period? 2 pi over 4, which is pi over what? 2. Doesn't seem like that. Is that right? What's your phase shift? No what? There is no what phase shift. Okay, you guys okay with that one? No phase shift whatsoever. So now you go, okay, we can do this. No big deal. We've been graphing for quite some time. I'm on graphing lecture 5. Jesus. 5. Okay, so we got the 2, what else? Negative 2, 2 pi, pi over 2, and this would now be what? 3 pi over 2. Is that right? Oh, I'm sorry. I made a mistake. What's the period? Pi over 2. Okay, because we're using this, right? Remember, we're using orange for period. It's the length of one cycle. All right, now, ladies and gentlemen, what is half of pi over 2? Did that worksheet help anyway? I might have to do some solutions on that, and that's on my to-do list. Doing solutions for you guys, even though I don't think I assigned it, but if you wanted to try it, that would be good. Okay. What's half of pi over 2? Pi over 4. What's half of pi over 4? Pi over 8. See how good you guys are getting with that? That's what happens when you go through and you practice that stuff. You get really good. And then 1 pi over 8, 2 pi over 8. This will be what? So it's pretty quick and easy, ladies and gentlemen. Okay, so then now you go, well, what do I do? I'm supposed to graph what? Cosine? How does cosine behave, if you guys remember? It starts where? Up here, goes to the x-axis, minimum value, goes to the x-axis. This is, again, that ghost curve, okay? Ghost curve. And I'm going to emphasize you have intercepts. This is for cosine. Your intercepts happen at what? Pi over 8 and 3 pi over 8. So in other words, you now have vertical asymptotes at x is what? Pi over 8. X will be where? 3 pi over 8. Does that look okay to you guys? What are vertical asymptotes again? There's vertical lines. They're not on the graph at all. But they're vertical lines that go through what? Right? There's vertical lines here. They're imaginary. Your curve never crosses those vertical lines. So how do we start to graph? Remember the reciprocal part now? Because we're kind of done. We're now graphing secant, ladies and gentlemen. Because that was the original question. So in black, I'm going to say if this was the maximum, we're going up forever. This here's the minimum. What are we doing? Going down forever, getting close to that vertical asymptote on both sides. And again, here we're going up forever. And for the most part, there it is. You're done. We could get rid of the ghosting information. There was no phase shift. But ladies and gentlemen, there it is. That's kind of the idea here. Let me try to see if I can get anything back. Remember, we liked bourbon blues. Is that right? You guys remember that one? Bourbon blues. Oh, restore. Oh, we have to restore the textbook. All right, so get my guys' textbook here. Okay. All right, you guys okay with that? There it is. There it is. Let's give you another example. I'm going to put some things together. Y equals cosecant 3x minus pi over 2. And maybe we're going to put another number here. Let's put a 1/2. Let's make it a good one. You might say, what do we really need to do then? You know, putting a number there doesn't really change much, right? It changes your amplitude. What's the reciprocal of cosecant, though? sine. And then what did we do yesterday? Did we scare people away yesterday with factoring out that leading term? Probably. I hope not, right? This is good stuff for you guys. You guys can do this stuff. You make it a priority. Remember about math. Make it a priority. And if you do that, it makes you a priority. So 3x minus what? Pi over 2. Remember yesterday? We're going to factor out what? That leading coefficient. 3x minus pi over what, ladies and gentlemen? 6. Good job. See, this is okay. This isn't too bad. All right, so now we go, here's the deal. A, K, B. Now we have a phase shift. Right, A is 1/2. K is 3. What's our phase shift? I forget the color. Brown, pi over 6. Was it green? Thank you. Dark green or kind of lime green? Lime, thank you. All right. Sometimes those colors help, ladies and gentlemen. Okay, remember, what do we get? We get the amplitude here, right? Amplitude will be 1/2. My period will be 2 pi over K, 3. And then my phase shift. Is my phase shift plus or minus? You guys remember? What's the phase shift? Be careful with that one. It's always what? X minus whatever comes after the minus sign is your phase shift. So it's positive. Remember, it was opposite. Always opposite for phase shift. Okay, so ladies and gentlemen, we now need the interval of what? Of one cycle. Now remember the definition here. You start at B, you end at B plus what? P. Pi over 6. Pi over 6 plus 2 pi over 3. So now 2 times 2, is that right? Man, I think I'm going to really do a worksheet. So is that pi over 6 plus 4 pi over 6, which gives you what? 5 pi over 6. You guys see what I'm saying? You get better and better if you start practicing that kind of arithmetic, because 2 times 2 pi, isn't that 4 pi? Right, and then 4 pi plus 1 pi will be 5 pi? So far, so good? All righty, ladies and gentlemen. So this is going to be the sine curve, right? So remember, we have to graph that sine curve. One half, what's this? Minus 1/2. Now, where do you guys start? Remember, the interval of one cycle tells you where to what? Start and what? End. So if it's positive, isn't that to the right? I know it's not to scale, so that'll be where we start, pi over 6. And then where do you end? 5 pi over 6. Okay, you okay with that? What do you need again? What's halfway? Oh, this is a nice one. 1 pi over 6 plus 5 pi over 6 is 6 pi over 6, which is pi, then divided by 2. Pi over 2. I like that. Okay, so hopefully we're good at our arithmetic because we've been practicing that. And then, what's midway? I might have to write this one down, right? You guys know what I mean? You go. You can do that first one in your head, but maybe not the next one. Okay. What do? Do you guys remember? We need the same denominator. So how do I get the same denominator? 3 times 3? Is that true? So 3 pi plus pi gives you what? Right, this will be 4 pi over 6 divided by 2. 4 pi over 6 times what? So I might have to make another, is that right? 2 pi over 6? You go, but Mr. Judge, I can simplify further. So that's pi over what? Is that pi over 3? Simplifying that fraction. So, okay, pi over 3. This is a nice one. Has some arithmetic. What about the next one? Pi over 2. 5 pi over 6 divided by what? 2. 8 pi and 5 pi gives you what? Or 3 pi, I gave you the answer. 8 pi over 6 divided by what? 2. Two pi over what? 3. So what curve are we trying to graph, ladies and gentlemen? Yeah, we're trying to graph what? Cosecant, right? But we have to graph first sine. So we got to get out the ghost curve. Start here, maximum value, back at the x-intercept, minimum, and back at the x-intercept, right? So we're going to sketch the ghost curve in honor of Halloween. But we're not done. We do want to locate these very special points because this is going to be the location of our what? Yep, vertical asymptotes. So impress your pre-calculus instructors with that knowledge. You go, where did you learn the idea of a vertical asymptote? Well, we're graphing reciprocal trig functions. X equals what again? Pi over 6. X equals pi over 2. What does x equal here? 5 pi over 6. Vertical asymptotes. These imaginary vertical lines that your curve never what? Goes through. So now what do you guys do? I always start here. You see the maximum value? How do we start drawing this reciprocal? Remember? This goes to the right, up forever, never crossing that vertical asymptote. Goes to the left, never crossing, forever. Then down here, goes to the left, never crossing, and then goes here, goes to the right, and you never cross. And, you know, you can get rid of the ghosting. And for the most part, there you guys go. There's your graph, ladies and gentlemen. Easy what? Easy peasy. It's a process. All right, so remember the process. You start with graphing that reciprocal curve, and then you do the vertical asymptotes, and then you actually do what? You sketch the reciprocal. The reciprocal is actually the curve here. And that's how you handle, generally speaking, these kind of curves here, ladies and gentlemen. What do you think? Okay, and now here's what I'm going to share with you guys now, okay? What other curves do we have? What's left? We did 4. Sine, cosine, secant, cosecant. What's left? Yeah, you say, what about tangent and cotangent, generally speaking? Well, I'm going to give you guys the general equation here, okay? Generally speaking, here's what they give you. They'll give you simply y equals tangent. Let me go back. Y equals a tangent x. Okay, and I forgot the k. Apologize. A, ladies and gentlemen, this is not a period. So I'm going to say here your k value we're going to use, but A is not really a period. That's only for sine and cosine, really. Okay? So I want you guys to know A could be positive or negative. They want k again to be what? Positive. So you use the even odd format again. But your period here is pi over k now, interval of 1 cycle. We're going to go through that. So your interval of 1 cycle now is going to be negative pi over 2k, pi over 2k. So this will be for tangent, ladies and gentlemen. And again, I'm going to put this in red here, not amplitude. So they should never ask you what's the amplitude for a tangent curve. It's not defined for it, okay? A could be positive or negative, though. And generally speaking, so if you look at your book and you go, Mr. Judge, when I look at the graph of tangent now, I always see this. This is only one period here. Okay, this is pi over 2k, and this is minus pi over 2k here. So your book gives you this nice description here. And to let you guys know, the tangent curve goes to the origin, and then it gets close to the vertical asymptotes. This is the general description this is only 1 cycle here. And again, remember the period is that distance. It's the length of 1 cycle. It goes from negative pi over 2k to pi over 2k. And this is when A is what? Positive. What happens if A is negative? Do you guys know? It's reflected. Is that right? It goes the other way. Right. It's reflected about the x-axis. You say, what do you mean? Put a mirror on the x-axis to reflect the curve. Going the other way, you're correct. It goes here and here. A is not an amplitude. A is not an amplitude for tangent and cotangent. It's only for sine and cosine. It's just a coefficient, right? It's just a number in front. It's not going to be 0 because then you got y is 0 is the x-axis, So that's why you only say y is positive, y is negative. Negative values for A just reflect this curve about the what? The x-axis. And that's true for any curve you guys see in your life, and you'll see that. So if you take pre-calculus next, guess what? They'll look at different curves and how A is in front, that negative value in front of different curves. Okay, they translate this stuff. Doesn't matter what curve it is. So, you do see it here as well, and I get to tell you guys about that. But then you go, okay, well, what's the graph, for example, of y equals maybe 3 less u tangent again, let's do pi x. I don't know if we want to do pi x? No, maybe let's do 1/2 x. We'll do pi x later. Okay? We're going to start with the period. You got to be careful. What's the definition? Pi over k. It's a different definition. Okay? It's not 2 pi over k. So what's k here? You guys know the value, k is always the number multiplied to x. So if k is 1/2, what's pi divided by 1/2? I might have to do that solution here, right? Pi divided by 1/2. You guys okay with that? It's pi times 2. You go, oh, my period is what? 2 pi. Okay. What was your interval of one cycle? Be careful, ladies and gentlemen. Is that 2k like that? You guys okay with that? Isn't that what we said it would be here? Interval of one cycle. So maybe you want to put that in flashcards. Put that period, put the interval of one cycle. K is what? 1/2. Do you guys know what 2 times 1/2 is? 1. Good. So, you get what? Minus pi and what? Pi. Interval one cycle. Now that's a good thing. You go, why is that a good thing? Remember, your tangent curve is going to be around what? That interval of one cycle. Not to scale. Pi, what's this? Minus pi. What happens over here? These are what? Vertical asymptotes. So if I want to summarize this, vertical asymptotes happen when x is minus pi and x is what? Pi. Those are called the equations of your vertical asymptotes, okay? So I can put this over here because remember, in beginning algebra, these are vertical lines, right? X is a constant. These are those imaginary lines, vertical lines you never cross. Happens to be where the denominator is 0. In other words, remember this here? I won't go through that detail, but anyway. Tangent is sine over cosine. This is where cosine 0, by the way. And then, do you guys know what I do? Maybe you don't know this. Maybe you do. You know what I think of? If you say, Mr. Judge, how do you remember what curve that is? Do you guys know this curve, x to the third power? This is a memorization device for me. X to the third power. You go, what do you mean? Yeah. How does that curve look? Good morning, Desmos. Let's get out of the calculus mode. I use Desmos for calculus as well. Y equals x to the what? Third power now. Okay? This is the curve. Y is x to the third power. but this goes up forever to the right and forever to the left. So when I say to students here, there's a good way to remember this curve. Get out the purple. How does that curve look? Looks like my blood sugar is pretty good today. Woo. Can't always get away with that, you know, so it's a good thing this is just a sketch. And then you go, but Mr. Judge, there was an A value in front, right? You go, Mr. Judge, what about that 3? You never even mentioned the 3. Didn't mention 3. But let's compare, just so you guys know. What do you think that even means, having a constant? It's positive. We drew the graph. You guys are done. You got the period. Interval of 1 cycle. I don't even remember what color we... Oh, it was pink. Pink. Okay. Remember what we said, the restricted domain. Let's go through all the analysis. Your restricted domain is the same. Negative pi to what? Pi. This is 1 cycle, okay? Because tangent has infinitely many cycles. Let's see if you guys can figure this out. This is for the A students. What's your range, ladies and gentlemen? What's the range of this? It is. Good job. Why? Because remember how you get the range? How do you get the range, really? You see every point on this curve? If you draw a what? Draw these lines. Horizontal lines. Wherever you hit the curve, the locations, and that'll be everywhere. This is your range. It's on the y-axis. So I just want to remind you guys about some of these kind of important questions, domain and range. And, you know, that's a pretty good deal, ladies and gentlemen. So you're starting to get an understanding of the curve. But nevertheless, let's go back to the constant A value, right? So let me remind you guys, generally speaking, about this, the constant. I'm going to get out my Desmos here. I'm going to say y equals. And some of you guys can try this at home. This is good. Okay, if you go, Mr. Judge, you're not showing me all the other cycles. I go, well, I just did. Oh, we graphed was restricted. Is that right? And I'm going to restrict this domain just for, I'm going to look at only 1 cycle. Do you guys know what 1 cycle here is for a tangent? It's negative pi over 2, positive pi over 2. So how do we do that again? Restricted domain, you get out the curly brackets. Okay. Then I have to put negative, there might be pi somewhere. You can spell it out. Negative pi, comma. Here we go. I think we spell it out, pi. Okay? I thought we did it that way. Isn't that how we do it? Do we have to put a comma there? Oh, negative pi divided by what? 2. Guess it would be good to have the correct interval, right? Why doesn't that? Did that do the restricted domain? Oh, it's set notation. Sorry. 0. Oh, I'm sorry, not 0. Less than or equal to x. Less than or equal. There we go. Restricted domain. Okay. Now, you guys know I kind of like doing what? I got to do the x equals negative pi over 2. I'm going to do the asymptotes. And then here, x equals positive what? Pi over 2. And dotted line. Red. Dotted line. Okay, you guys see how I'm consistent with that for you guys? That's just tangent. That's not the one we're looking at. But then if I do what now? Let me put here. Does it let me put A? It might. Ooh, A. There we go. What happens when I add an A value as I increase? It just gets, it gets what? This is A is 3 now. Okay, if I scroll out, it just gets sharper, closer to the, it doesn't get as close to the what? To the vertical asymptote. Can I get a fraction? Yeah, what happens when A is a fraction? Notice this. Then it's what? If you get a fraction of these values. These are fractions. This is how the value of A changes. We just have to sketch this curve. A is positive, okay? What about A being negative? Goes the other way. Remember what we're saying? So negative values for A. So all we have to do is sketch this curve, okay, for A. So I'm glad it does that. A is negative 1/2. It's negative. It's reflected about the what? The x-axis. But when A is 3, the one I just did, with that, it's not even an amplitude. It's just a coefficient, just a number. It does make it. It does change the shape. Now, do we really need to be that accurate if we're going to sketch these curves? The answer is what? No. Okay. So I just want to let you guys know that A value isn't such a big deal for tangent and cosecant if we're sketching. It is a big deal for sine, cosine, and then thus secant, cosecant. But this is kind of all the analysis you do for tangent, ladies and gentlemen. This is the tangent curve. This was that what? A value we just discussed. But it's actually, we didn't do 1/2. Okay? We could, but all right. And obviously, if they did what again? What's the sketch if they put a negative there? You go, oh my God, they put a negative. Well, guess what? Sketch it this way. You're reflecting about the x-axis, ladies and gentlemen. So if they put that negative sign, there you go. There it is, if it's negative. Excuse me? Well, bigger the number, the thinner the curve. That's a good way to look at it. Okay? The bigger the A value, if A is greater than 1. If A is less than 1, but positive, it looks more tangent-ish, if you want to think of it that way. It looks flatter, getting closer to that x-axis. It's those pictures. And in all honesty, you know, Desmos is a website. Do you guys know that? It's not even an application. It's a free website. So some of the things I'm showing you here, you can, you know, you don't want to do it on a test, but, you know, maybe you want to verify restricted domain, and you can verify for yourself. And you go, oh, okay, I see what we're going with this. It's all a learning tool, all important. Okay, you guys okay with this? All right. I promised you pi. What if they gave you y is now tangent? You go, Mr. Judge, what if they do a pi x here? Okay, they do a pi x now for tangent. Well, what's this value again? This is k. Oops. Period is what? Isn't that pi over k by definition? Because this is tangent. So what's my period going to be? Yes. Period is 1. Orange. What's the interval of one cycle? Minus pi over 2k by definition. Pi over 2k by definition. Okay, you guys okay with that? So yeah, what was k then? You said, but k is what again? Pi. So I'm going to put pi over here. Pi over here. You know it cancels. Interval of one cycle is going to be now negative 1/2 what? Positive 1/2. There it is. What do you guys think? Easy breezy? Easy breezy? What do we say? Lemon squeezy? Easy breezy, lemon squeezy. All right, so then we need our what? Vertical asymptotes, right? What do the vertical asymptotes happen at? Do you guys know? That's why you found the interval of one cycle, these endpoints. X is negative 1/2. X is what? Positive. You got vertical asymptotes. What's the coefficient in front of this tangent? What's A is 1. Is that positive? It's positive. What do you guys think? Pretty good? Easy breezy, lemon squeezy. Then let's see if you're really awake. Note. Because the book, it's kind of interesting about your book. The book didn't explain this. You know what your book just did? Remember this from yesterday? There's a phase shift, but your book doesn't really talk about it. It gives you an example, though. I just want to let you guys know that, okay? So what do I do here? 4x minus pi over what? 4. So this question, in some ways, is 2 tangent 4x minus pi over 4 here. Okay? So what I want to really emphasize is, yes, this value is important, k, right? Because the period is pi over k. What's pi over k? Yes, pi over 4, right? And then you go, okay, but my interval of one cycle is defined to be minus pi over 2k, positive pi over 2k. But what did they just do? Like before, x minus, I think we used green. What do they introduce now? This is a what? A phase shift value. Okay, you guys okay with that? So you go, Mr. Judge, you can have a phase shift? Yeah, it's just horizontal shifting. So what does that even mean now? Because your book didn't give this to you, but I'll give it to you. You know what that means? Here's your real interval of one cycle. You remember what we do? How do we do that? Isn't the interval of one cycle going to be what? B minus pi over 2k, and then what? B plus pi over 2k. Remember, this is now going to be where you what? This is where you start. because we're shifting to the right, and this is where you what? End. So Mr. Judge is here to do what? Save you if I can do that, some grief. Give you some, save you from that. So what was K again? What was B? Pi over 4? Okay, so here's my interval in one cycle, right? Pi over 4 minus pi over, what's 2 times 4? 8. Pi over 4, what's this? Plus, oops, where did I get that to? Plus pi over what? 8. So every time you have that phase shift, you put that B in both locations. Moral of the story. B goes here, B goes here with the interval of one cycle definition. And then, I hate to say it, we're going to have to do some what? Arithmetic. 2 and 2. So let's see if you guys are really awake here. What's that interval of one cycle? Starts at pi over 8 and then does what? Oh, another arithmetic question. 2 and 2. What does that give you? Yeah, 3 pi over 8. So that's a pretty good deal. So they do give you that phase shift there. Just looking at the homework. But you guys know how to handle that. You get the B in both locations. So now you go, okay, isn't this where we start, right? You start and you what? End. So we start where? What do you guys know? We have to start where pi over 8 is, right? This is pi over 8. Draw your vertical asymptote. And then over here is going to be what? Yeah. And you can put it up here. Okay, so it's good to notate vertical asymptote. X is pi over 8, X is 3 pi over 8. So remember, this is that interval of one cycle. But you have an issue. What's the issue? You need the midpoint, and they didn't give it to you, did they? Or did they? What's the midpoint? Pi over what? Is it pi over 4? Let's see if this makes sense. Why is that pi over 4? You took pi over 8 plus 3 pi over 8. You divided by what? 2. What does that give you? 4 pi over 8 divided by 2. 4 pi over 8 times 1/2. Is that right? That's 2. So sure enough, your arithmetic says pi over 4. Here's the arithmetic, ladies and gentlemen. I guess this is the S portion. So does that make sense? Say yes. Why does that make sense? This was our phase shift, is that right? Is that the phase shift? Yes. I think I'm coloring it the wrong color. Purple. No, it's not purple. I don't remember. Isn't that the phase shift? What do we mean with the phase shift? You moved this curve from this point 0 is now where? To the right, pi over 4. So that makes a lot of sense. You guys see what I'm saying? Because this is Everything moved a distance to the right horizontally. That's to the right, pi over 4. So now I get to draw my curve. Oh, I love my blood sugar being low. I'm going to tell the doctor. You could use the phase shift. That's exactly it. But what I do is I want to verify it for people because it's always great to. It's wonderful when math is consistent. Math is consistent. First of all, math is never inconsistent. People are inconsistent. Meaning we could make a mistake or we could just not understand properly. That's what I mean by that. But the math should be consistent. So when I show you guys this midpoint, and then I go, oh, look at the phase shift. Everything moved to the right, pi over 4, all these points. It matches. It should be. It should be consistent. So it's kind of to me, that's the beauty of studying this subject. Now I get to talk about, the poetry of mathematics, which is that it's what? It's consistent. It's a consistent, discipline-filled topics in a very inconsistent world. That's for me what makes it what? Special. I could go home and everything doesn't make sense around me. None of it makes sense. It's nonsense, But here, with these questions and problems, it's always consistent. That to me is a very beautiful thing. This is why I love, this was my escape from the irrationality or the inconsistency of life at home and the world around me. When things don't make sense, this always makes sense. It's kind of a gift that it gives to you. I know. When I start talking this way, everybody goes, oh, okay, that's when people lose it. But do you guys see the consistency of what I'm talking about? And again, 2, that positive 2, what if they give you a what? Negative now instead. You go, oh, do I have to do everything all over again? No. It would look how if it were negative? Just draw it that way. If it were negative. Let's see, hopefully we have time here. 2x plus pi. You say, I got to replace this with what? 2x plus pi over what? 2. We did that factoring yesterday. And then, if you're really awake, x minus 8 minus what? Pi over 2. So you really have tangent of 2x minus a minus pi over 2. K, and I guess it was lime green. Okay. So what is K again? K is 2, and then my phase shift B is negative. Why is that negative, ladies and gentlemen? Because you got x plus. You write it as minus a minus. So this means your phase shift is going to the left, not to the right. Is that right? It's a left shift. Okay, period now. Pi over k, that's pi over 2. My interval of 1 cycle now, you say, is that b minus pi over 2k? The book didn't give me that formula. The book wanted you to deduce it yourself. Okay, so now I put my b value here, right, and the k value. down here. We desperately need that interval of 1 cycle. So b will be what? Negative pi over 2 minus pi over 2 times 2. Negative pi over 2 what? Plus pi over what? 2 times 2. There you go. What do you guys think? Pretty good? I'm just using those definitions. So I would say get out some flashcards and do some what? Memorize those definitions. That's how you make your progress, ladies and gentlemen. It's not about people who are born with this. I wasn't born with it. In fact, I can tell you guys a crazy story. You know my trig instructor? He was crazy. You might say, Mr. Judge, I already know that stuff. You guys know what I mean? You don't know. I mean, he was literally nuts. He didn't know, he forgot trig. He didn't know trig. He lost his marbles. So we would come in, we were in the dark. Well, we're in the dark here too, but no. Without a projector. Turn out the lights, put you in the dark. Went up to the podium. I guess he was afraid of light. Try to read the book and figure it out. We spent crazy. So what I had to do was read the book. They finally removed him because he lost his marbles. Isn't that interesting? He was older. Something. It could have been dementia. He wasn't that old, though. He wasn't. I mean, he might have been. I don't know. He might have been retirement age. It's possible. But I hate to tell you guys, people lose their what? Marbles. Even math instructors. So I'm going to do this here. I'm going to do all my arithmetic because of the fact that you said, Mr. Judge, you had to learn all this on your own? I'll tell you, yes, I had to learn it on my own. How do you think I learned it? Reading and what? Practice. And reviewing every time I needed it, and I needed it all the time, So I think for you guys, again, having these resources, going through this the way we do, it's very important for you. Because you see these ideas in science classes, right? So you have the x-axis and the y-axis. So let's do this. Go all the way to the what? My first vertical asymptote is what? Negative 3 pi over 4. Then I also have another one. I'll just put it like over here. It has to be negative, okay? It is not to scale. And then I have that. I have the horizontal shifting. What is this? What do you think that is, ladies and gentlemen? What is it? Negative pi over 2. So you say, Mr. Judge, can I just say negative pi over 2? Yes, you can. Can you add these numbers and divide by 2? Yes, you can. What do you think it'll be? Negative pi over 2. All right, you guys okay with that? And then you go, what is this? A tangent curve? There's no minus sign in front of that. So if there's no minus sign, we just do what? Remember the x to the third power curve. Okay? That's what I remember in my head for this curve. There you guys go. All right, you guys see where we're going with this? Okay, so if I look back on the website, tangent, okay, cotangent curve. We're going to have to look at this thing here. Now, remember, we have this idea here for k here, right? And we want k to be positive. This is how everything's defined. Now, cotangent curve looks a bit different, so I'm going to give you the information here. The period is still pi over 2k. Your interval of one cycle here, ladies and gentlemen, is going to be 0 to pi over k. So what I like to remark, tangent and cotangent have different what? Intervals of one cycle. They have different curves, and I'm going to express to you in general how this looks, just the way the book does. And remember here, this value A is not an amplitude, okay? It's just a coefficient number. Okay, I'm going to just write that in our notes. This A is not an amplitude. That's an important detail. A could be positive, A could be negative. It doesn't represent the amplitude. It's not part of the definition. Okay, it's just like we call it a coefficient in terms of a function. Let's say that again. Amplitude's only defined for sine and cosine, really. So you only have it for sine and cosine, but it's there in general of all functions. Like, for example, not in this class. If you said, boy, how do you graph the function 3 over x, right? Well, that's an a value times 1 over x. You want to know how the curve 1 over x looks, and then that value in front could be positive or negative, coefficient. Then that has implications about the graph, right? It could be sharper, or we should say skinnier or wider. Remember those kind of ideas, skinnier or wider curves. Or it could be reflected about the x-axis if it's negative, So generally speaking, like when you take a pre-calculus class like this class, yeah, that a value is talked about. It's just a coefficient, okay? But it has special meaning only for sines and what? Cosines. In that case, they call it an amplitude. It's not just an a value. It does work the same way. They just gave it a name. Yes? A determines both how wide and thin the curve would be. It also determines whether you reflect it about the x-axis, if it's negative. So generally speaking, like, I know this is like if you had maybe -2 square root of x, right? Well, you want to know how that curve looks. And then you want to know the effect of the coefficient on that curve. Really, it just means reflected about the x-axis because it's negative. And then it could be the wide and skinny again type of thing, Essentially, wide and skinny is based on whether it's a number greater than 1 or a number between 0 and 1. Like if you had the coefficient maybe 1/2, then that's different than having the coefficient 2. So just that kind of knowledge. And the good news is, when we get away from the high school environment, nobody's going to make you plot points for days, comparing 2 square root of x and square root of x or something like that, So if I just said to you guys, okay, let's go take a look at Desmos, right? Just to kind of confirm a little about what we're discussing, right? Discussing here in general about curves. Okay, here's again, cotangent's periodic. We're going to see what that looks like. And then if I just said to you, okay, what if I had y equals, for example, 2, and you guys already know I reserve red for other things, and I already go, 2 cotangent, and then you have y equals, for example, let's get our coefficient first, 0.5 for 1/2, right? Cotangent, as you start to see, if I restrict our domain here, and I won't do that, but if I just look at the first 0 to pi over 2, I believe, or 0 to, what is that cycle? 0 to pi, I guess. You guys can see the effect on the coefficient. It's still the same kind of curve, right? Same curve, but that coefficient makes it skinnier or wider type of thing. That's all. We don't have to spend our days trying to plot those different details. The second you put a negative, y equals negative cotangent again, what do you guys notice? If I get rid of the skinny and sharp, you guys notice that it's reflected about the x-axis with the negative sign. So that coefficient has a lot of meaning for us that we look at, okay? It does have a lot of meaning, and that's what you start to study in a trig class, but you study it in great detail in a pre-calculus course. But in there, you have a lot of other curves to consider. Yes?
So the negative is worse because yesterday we said that the curve on the left side was negative.
Well, be careful. If you tangent and cotangent are graphed differently. They're actually opposites in a way. I'm going to share with you guys that. Like, you bring up a good point, right? When you say, this is what I understand. Remember what I told you guys? This is going to be for what? Tangent, right? And that's how tangent looks, the x cubed. But then you go, well, what about this cotangent, right? Well, cotangent in general, the memorization device that I have here is remember a few things here, right? These values are extremely important. It just isn't that you have that interval of one cycle. I mean, that's important enough. But you have vertical asymptotes at x is 0 and x is pi over what? K. Okay? So it has those imaginary lines you just never cross. These are all imaginary vertical lines. And I'm going to put it on this side instead because I'm going to use this here. So you might say, some books will say, here, this is all the real detail. And then halfway, again, halfway, that would be pi over half of, from 0 to pi over k is 0 to pi over 2k. That's halfway. And then you say, well, how does a curve look? Well, remember my memorization device? I think of it this way. Because this is going to be for cotangent now. This is not tangent. So the graph of cotangent will look like this. And let's see if my blood sugar level is... It's getting better. I'm going to see the doctor soon. Yeah, I'm diabetic, so that's an issue. Anyway, that's the curve minus x cubed. Okay, that's my mind. I always remember that minus x cubed for cotangent. So if you go, oh, is that why you have here? Let's get rid of it. Look at cotangent. You're going through pi over 2 because k is 1. Interval of one cycle from 0 to, remember, 0 to, if k is what? 1, that means it's pi. So I'm going to restrict our domain again, 0 to pi, just to be very accurate. Okay? 0 less, let's go back. Well, actually, that's technically correct. Okay. So if you said, what did you just do? I filled all the other cycles because tangent, all these functions are periodic, meaning there's other cycles to consider. So we usually focus only on one cycle. Our life's complicated enough as it is, one cycle. We don't have to graph all cycles, okay? Yes. Question. What's that? Well, negative cotangent would look a little bit like tangent, but it is shifted Yes. You know, so it is shifted. Y equals like negative, for example, x cube here, right? If you said, oh, Mr. Judge, is that what you kind of remember? Yeah, it's not the same curve exactly. Of course, it's shifted, but in my mind, we're sketching. And that's why when I put in the notes here for you guys, this is kind of what it reminds me of. Those of you guys that maybe are taking a pre-calculus course, you should know about that x cube curve. And generally speaking, like I said, you say, Mr. Judge, are you serious about this stuff? Yeah, let me share with you guys. When you get to a Calculus 1 course, I have worksheets and videos there too. And I have this curves what every B-STEM student should know. And it's based already after you took a pre-calculus and a trig class. And as you can see, it's actually in the format of looking at these fundamental curves. Oh, there's your x cube, x to the fourth, and so on. All these curves, I give that, you know, that you study in these courses here. And then you get all the way back down. Those are the logs and exponentials here. And then you get back, then you get to the trig functions, right? Sines, cosines, secant, cosecant, tangent, cotangent. So I just kind of, and then you have the relations, okay? So, you know, I give this stuff to students because of the fact that in a calculus course, you've studied all those basic curves. And then how you translate them, move them around, you've studied as well. So that comes to use in a calculus course, ladies and gentlemen. So, yeah. Anyway, so and the good news is, we're still graphing what? Cotangent here. So we got to study those things. We got to look at these examples. And you say, well, what do I do? Well, you use the definitions I gave you. Okay, you guys know what I'm saying? So if they say to you, okay, what's the graph of cotangent of maybe just start simple 2x now? Right? Start simple. And you go, what do you mean simple? Well, what's k? K here is what? 2. Doesn't everything start with that? So that number times x, and then you go, well, what do I do with this? Notice k is positive. So my period then becomes, what's my period? 2 pi, well, no, what's the definition of period? Pi over k. We got to be awake about that stuff. Is that right? You guys know what I'm saying? It's not the same as sine and cosine. The period for tangent and cotangent is pi over k. So we're going to say pi over what? 2 is for our period here. There you guys go. Okay, you guys okay with that? You guys see what I'm saying here with this stuff? Okay. What's the definition of your interval of one cycle when it comes to cotangent? 0 to what? It's really 0 to what? The period, ladies and gentlemen. You guys know what I'm saying? So it's 0 to, in this case, pi over 2. And I don't remember, and let's color that pink, right? Don't remember the color. And then in some ways, at this point, we could just say, since we're going to sketch a curve here, let's note the what? Vertical asymptotes. Vertical asymptotes happens at x is what? 0, and x is pi over 2. So those of you guys that are taking that course again, and even if you're not, you study it here as well, you know. You guys know what I'm talking about. You go, oh, those are the lines that we never what? Cross. So here's what we have. These vertical lines. X equals 0. And x equals pi over what? 2. There you go. Okay, you guys okay with that? X equals 0, x equals pi over 2. And what's the one thing you always want to do? You see that middle point there? Remember, how do you guys get midpoints? You add the values and divide by 2. Remember that? I'm going to share with you guys some more worksheets I have. So we need to plot this point. Right? So you say, how do I get that? Well, 0 plus pi over 2 divided by 2. Is that right? And that means you get pi over 2 divided by 2, or simply pi over 2 times 1/2, which gives you pi over what? 4. So ladies and gentlemen, this is pi over 4 here. Okay? So we have all of these important points. Sometimes people just put 0, pi over 2. You might see that on solutions there, right? But be careful, because now you get to sketch. You say, what do you mean I get to sketch? What do you have to sketch? Which one? Cotangent. You guys, if you say tangent, you're going to miss that. So you got to remember, we're sketching what here? Cotangent. What do you think of again? In my mind, I go, oh, the opposite of this negative x cubed. I got the wrong color. Okay, so it goes hell. Gets close to the vertical asymptote, never crosses, and there you go, ladies and gentlemen. This here is the graph of what? Y equals cotangent to x. Those are the steps using all the definitions that you need. And here's the thing. When I ask on a test question these things, you know what I ask for? What's the period? And I give you a check. You guys, so remember, this is kind of something, this is a framework. You want to start getting things right, as you go along. Then I say, well, what's the interval of one cycle? And I'm looking for what? 0 to pi over 2. And you go, okay, another check, really. They got the right interval of what? One cycle. That's 2 checks. You say, what are the vertical asymptotes? That's what? Another 2 checks. And then I look at the graph. Do they sketch the right curve? It's the last check, maybe. So if you put tangent versus cotangent, well, you won't get that last check, okay? So you might say, hey, is this partial credit? And the answer is, yeah, it's partial credit, but it's based on the things you do right, not the things you do wrong. It's not a creative essay. You know what I mean? You got to start getting used to getting steps right. Some students want a creative essay type of grade. Yeah, is that what it's? So that's what I'm looking for. Which one? I don't really like, for example, the subject, what do they call it? It's very subjective. I mean, they, in theory, should define the matrix I'm saying to you guys too, how they grade, in theory. And then when they are subjective, at least you can document the things that we're looking for, idea. That's what I believe. So for me, if you look at the check thing, you go, oh, that's why he does those checks. And, because I'm looking for stuff. But it's not, oh, you did sine when you should have done cotangent. Oh, let's give you partial credit type of thing. You got to know the difference between, what curve you're looking at. That's important, So this is kind of, again, how we look at some of these curves here. I want you guys to note something here, or by the way, and I didn't talk about it with the others, but, if you had something like this, and you wonder, but Mr. Judge, that K value, you told me K must be what here? Positive. Oh, where is it? Over up here when we described it, right? K is positive. You go, what? Well, they gave me a negative there, right? And you go, what's happening? K is supposed to be positive. You see, what they're saying is all these definitions apply when K is what? Positive. You must have a positive K value. So all the definitions will apply when K is positive. If you see a negative K, what do you think they're trying to have you recall? Remember this? What does that really mean here? What do they want you to think of? Is this cotangent, what's the word? Even or odd? Is that right? So remember when we studied that, I mentioned to you, this is important in what kind of things? Like for graphing, you know. And what do you guys know? Is this even or is it odd? Well, I might look at it this way. What's the definition of cotangent in terms of sine and cosine? Isn't it what? Yeah, it's cosine over what? Sine, is that right? And then I go, okay. And, you know, this is cotangent. And I know cosine. Nope. Let me be careful. Cosine is what? Is even. Is that true? So that means this is cosine 2x. Sine is what? Odd. So it's minus sine 2x. So then this is a minus what? Cosine 2x over sine 2x minus cotangent of 2x. So ladies and gentlemen, what does that mean? Cotangent is what? Is odd. I can pull this out, and now this is minus what? Cotangent 2x. And so if you had to sketch that graph, everything's the same. Is that right? But it is reflected about the what? We say reflected about the x-axis. Anyway, and that graph would be now like this in red. Okay? Just to share with you that little detail. Okay? Because you put a mirror on the x-axis and then it's every point is reflected, right? You just put like a mirror here and you tilt it back and forth. And then you go, oh, every point is opposite there now. And that's it. On the opposite side, opposite of the plane. And that's the effect. All right, you guys okay with that? Easy breezy? Lemon squeezy still? So what they say, okay, give me 2 cotangent. Now, 1/3 x. What's this k value? What is this? What's your period? Pi over k again? Remember that arithmetic every trig student should know? Boy, I think I'm going to redo that. I don't know. What is this going to be? What does that equal? Do you guys remember? It's pi divided by what? 1/3, which will be what? 3 pi. So the period equals what? 3 pi. Okay, interval of 1 cycle. What do you guys call that one? Interval of 1 cycle goes from 0 to the what? Period. Is that right? Is that 0 to 3 pi? Okay, there we go. And that means my vertical asymptotes happen at x is 0 and x is 3 pi. Okay? So you guys are good with that. All right. So what do we draw first? So we have to draw the what? Yeah, the vertical asymptotes, right? And then make sure, I mean, I'm not going to move everything. We're going to do it like this, I guess. So that's like where 3 pi would be. This is where 0 would be here, right? And remember, you always need that halfway point. It's going to go through that halfway point. It has an x-intercept. So maybe you go, oh, maybe we should ask, what's the x-intercept? Because that's on the x-axis, right? What's the x-intercept? 3 pi over 2. It's halfway between 0 and 3 pi. Halfway between those two numbers. You add them. 0 plus 3 pi is 3 pi. Divide by 2. There you go. Okay, you guys okay with that part? What happens now then if I said to you, oh, what curve is this? It's cotangent. What do you guys remember for cotangent? I have in my mind minus x cubed for cotangent. So when I sketch this curve here now, there you go. There it is, ladies and gentlemen. And again, it's only one cycle. It's periodic. Ah, thank you. You're awake. Negative x cubed. Good job. Just testing you guys. Just seeing if you're awake. Okay. All right, you guys okay with this? I'm going to have you guys try a few on your own. No. You guys are scared? It's not Halloween yet. I didn't share with you guys my Halloween stories, right? Oh, I better not. I might scare you guys. Then you say, Mr. Judge, you're scaring. I think I'd share with you guys that story, right? We asked you if you believe in ghosts.